I'm a family man, dad of 3 girls, amazing wife, embedded software for about 20 years, multiple agile transformations, and a passion for improving state of the art. So always been throughout my career looking for ways to improve things, and over the last couple of years have been recognizing that embedded is sorely behind all my friends in the web and mobile space have all the cool tools. There's been a lot of innovation in that space in the last 15 years. And embedded is way behind. So I'm really excited to be talking to folks today about getting embedded to a better place and helping them hopefully set up find some ways to set up CI/CD and lower the bar to entry there. Dojo 5 real quick is a group of embedded software experts out to modernize the firmware lifecycle. Dojo, we're about immersive learning, and that's part of what we're doing today is reaching out to the community and talking about hopefully teaching some folks some new skills or teaching them about some tools that they didn't realize were out there. And then 5 is our foundation and family. I've got 5 folks in my family and wanted to bring the family feel to our office. So we're a product and services company based in St. Paul. Real quick, the plan: we're gonna set up drone, do a hello world CI, and then make sure we're all set up, and then kind of focus really on the pieces that are really embedded specific, and what does it mean to pull in the embedded pieces to this? Because a lot of the CI tools are set up to make web development or mobile development really easy. There's a lot of blogs and documentation on how to do that usually, but not as much on how to do embedded. So real quick, concepts on drone. It's what I call they call themselves a modern CI tool, containers first. And like when you think about some other competitors, like Jenkins is another big one. We just had a lunch and learn about that on Wednesday. One of the big differences between drone and Jenkins, because in some cases they do the same thing, but drone is really all about like everything happens in a container. There are a number of plugins that are containers, and then all of your builds happen in containers. Jenkins didn't always have containers. They weren't containers first, but now they've added on containers. And if you don't know what containers are, we'll get to that in just a few slides. But drone's been around. I mean, they did have their first check-in back in 2014, but they really have been kind of hit the scene here in the last just year or two. You can see their 1.0 release was just last year. And now they're still on the 1.0x series, but then just a couple days ago released 1.8. So they've got a few, and they've seen a lot of frequent releases over the last couple of years. There are 2 versions that they have. There's kind of like what I call the community edition and the commercial edition. They don't quite use these terms, but that's pretty much what it boils down to. There's an open source edition that has fewer features. Unfortunately, as we'll find today, there's that community edition does not allow you to have distinct runners and agents like doing your builds. And so we're going to run the commercial edition today, and just know that their pricing model is such that you have to negotiate it with them. They don't publish their price for the commercial edition but you are allowed to use the community edition if you have less than 5 million annual revenue or less than 5 million funding, or if you're less than 5,000 total pipelines in the prior year. I can imagine in some bigger companies it would be tough to get that those stipulations through, but through some kind of sourcing acquiring place. But for smaller companies, it's a pretty easy place to be, and even if you're just hitting the pipelines side of things. As I mentioned, agents are a big enterprise-only feature, unfortunately. Storage options other than SQLite, runner options beyond Docker. Honestly, the SQLite and Docker pieces aren't a big deal, but the agent piece is kind of where we'd have to get a little more creative to do some of the embedded stuff. I think there's ways to do it, though. So from a hosting perspective, where do we host? For the cloud, we got the usual suspects. On-prem, all these instructions will still apply. I'm going to show it using DigitalOcean today. The concepts for Docker. Docker is basically, when I mentioned containers before, that's what Docker is. It's a fairly It's getting to be a mature tool now. It's probably been on the scene for 8 to 10 years. It's basically this idea that, you know, when you do a build, when you do a continuous integration build, you want to package up your entire environment and be able to have reproducible, rapid, reliable builds. And reproducible piece of that and reliable both kind of blend into why Docker becomes such a valuable tool. So, you know, previously when people had tried to do some types of build automation, they just grab a Windows box that was, you know, sitting at somebody's desk, you know, and maybe an extra one, an older one, and they just install the compiler tools on it. And then they just, you know, you start with a batch file maybe that like runs your build, and then you start it up, you know, find some kind of cron job or some way to run it on a regular basis. And all of a sudden people started putting, you know, web interfaces over it. And now that's great, but the thing is, like, is it checking out your code every time, you know, and is there a possibility that like files that get deleted on your source code control, you know, would stick around, you know, in your file system, or would there be extra binaries that get generated from build to build that would, you know, wreak havoc on your build from, you know, from time to time? And then, I mean, the whole idea is you never want false failures. You never want false positives. You always want to know the true state of your system. And so that's what Docker really helps us do, is it isolates the file system. So and basically the entire file system that's available at the container, all of its tools, all the binaries that it needs to use, all the compiler tools are all contained within this container. And it runs on top of your system. The other tool that we had previously used in the past was these VMs, or virtual machines, like VirtualBox or VMware. There are others too. And those are just fairly heavyweight for computers. There's no way to run like multiple containers or multiple virtual machines unless you need a pretty beefy machine. The more of those you add, they just chew up a lot of RAM and a lot of CPU because they are virtualizing the entire computer. So containers are really in a really revolutionary technology in the last 10 years, I'd say, as they've allowed, you know, in the web and mobile world, not only do they build within containers, but they actually deploy to servers with these containers. So it becomes even like their deployment mechanism. So it's been pretty revolutionary, and I believe that we're just hitting we're just touching the tip of the iceberg on embedded. And there are actually a number of companies that are even using containers as a deployment mechanism on embedded devices. So they see the value and they're trying to bring it to embedded too. Real quick, concepts of Dockerfile, because we're going to kind of get into this as we go, but this is a portion of a Dockerfile. It's basically a set of steps. You could almost look at it like a script that builds your build environment, and that's the way we're going to use it today. Here, for instance, it's part of a Dockerfile that creates a Nordic development environment using their Sega Embedded Studio, and you can see there's a from command, and it basically bases itself on an Ubuntu 18.04 image that has been defined elsewhere in a different Dockerfile, but that's how you can kind of build these Dockerfiles on top of each other. So this one is based on Ubuntu 18.04. And then we run some commands. apt-get, if you've done some Linux stuff, is basically their package manager. And so we install a number of dependencies for the Sega tools and the Nordic stuff. And then we install, you know, and then here's a different install using pip, which is a Python package manager. So we're installing our dependencies. Here's some magic that helps us run something that was originally meant for a GUI, but inside of Docker, it doesn't really have any UI or visualization ability, unfortunately. So, you know, and a lot of times for automated tools that you want to run from the command line, that's okay. But if you run across a tool like Sega Studio's installer that does not allow you to do that, then you need some, you know, magic inside the Dockerfile. But, you know, you can typically find this either in, you know, in my slides or online. And then you basically run your steps to build up your build environment. So yeah, and that's probably all the more we need to know now. You know, if you decide to move ahead and do a CI/CD, you know, server like Drone or like Jenkins or one of the other tools, you'll almost certainly be writing a Docker file for your environment and need to be pulling together some of that, or finding one that somebody else has written. There's a pretty large group online. So let's get started. We want to set up drone. I have a, I'm going to be setting it up on a cloud-based provisioning platform called DigitalOcean. And we are going to set up our primary drone instance, D5 primary, we're going to call it. And then we're going to base it on drone/drone:1, which is, if you haven't seen that terminology before, it may look a little funny, but that is referencing a Docker image, or a Docker image that the drone guys have created. And it installs, it's from the namespace drone, and it's the image drone, and it's basically the version 1.x series is what we're referencing here. So let's pull that together. So here we are, DigitalOcean. All right, so I'm going to create a droplet. That's what DigitalOcean calls its little compute nodes. And we are going to base our compute node on Docker. All right. And we can, I'm going to pick the 2 gig one with a little bit more space, or a little bit more RAM, I guess, just because we're going to be running a few other things on this device. But otherwise, we can keep all of these settings the same. There's a lot of things that we could go into here. Don't have time now, but very happy to answer questions offline as we get going. This is SSH key so that I can connect into to the box once it's up and running. I've preloaded my SSH key here, and that basically serves as our password. And then we are ready to build it. I'm going to rename it here right now to D5 primary. And we'll create that droplet. That'll take just a second. It's kind of amazing how fast it goes. And then in this case too, I'm actually going to be assigning what they call a floating IP to this droplet, and that gives me an IP address that I can count on, and it allowed me to put together some of the scripts for later in the demo that would rely on this IP address. Otherwise, when you start up and shut down these droplets, they kind of do they get kind of a random IP address from wherever. So here you can see our random IP address. And if I were to delete this and start it up again, it would get a different one. But I am going to also assign it this, this floating IP I got. Oh, good. All right. Here we go. All right, assign floating IP. Uh, 0.59 is actually the one we wanted to. Sorry, I think it logged me out. Let's try reassigning to a droplet. There we go. There we go. That's what we wanted. 0.59 to D5 primary. All right, so now we have a device up in the cloud. Let's go talk to it. All right. So I'm going to pull up. There it is. Oh, I'm full screen, that's why. Okay. All right, so here we got a drone directory, and I've installed a tool called DigitalOcean Control, or DO Control, and it lets me do a few things from the command line. This just allows me to very quickly and easily SSH to these devices. And we're going to SSH into D5 primary. The very first time you're going to get this fingerprint check. You can say, yes, this is the right computer, and we're in. Now we're logged into a device, a compute instance that's running on the cloud. Head back to our instructions. So, and by the way, I'm just following a lot of these steps are available both server provider GitLab here, because we're going to be connecting up with GitLab, or right here with the CLI install. So, and I've got my cheat sheet here of some of the things that we need to do. So there's a couple things that we need. The way that drone gets installed is this big long Docker command right here. And there's a couple things that we need to have available to us before we can run it. And I'll just show you how I'm pulling that in. They all come in through environment variables. So here's the environment that I put together. There's a GitLab server, which we're just going to be on gitlab.com today. You can host your own GitLab too. So there's some options there if you want to do things on-prem. We have a GitLab client ID that I set up ahead of time, and a secret. There's actually a GitLab client ID and a GitLab secret ID that I'm keeping separate in this environment secret area. And then there's an RPC secret that that's used for our primary instance to talk to our worker when we get to the worker. There's the server host, which is our 0.59 here, and then the server proto, HTTP. These are some other things as we get further on in the demo that we're going to use. But for now, these are the pieces that we need to get our server up and running. Real quickly, let's see if so. And as I mentioned, I'll just say that this GitLab client ID, you have to add a new application into your GitLab setup. And if you haven't done that before, it can be, yeah, I'll just show how real quick how we're doing all right on time. So here I've got, if I go to my personal settings and I go to applications, this is where you would say drone, and then you need to put the redirect URI. We're not going to be using HTTPS today just because that adds extra level of complexity and needing domain names and stuff. But if you do deploy this for real, that's definitely something you'd want to do. And then you'd give it your IP address, and then /login. And this is all on that site. You need to give it API access and read user access. And then once you create this, you'll get something that looks like this. Yeah, and in this case, actually, we do need to create a new one because I need to change the redirect URI. So it's important to have the right redirect URI here. There we go. So we'll save application here. And now we get an application ID and an application secret. Let me move this out of the way. There we go. So, and as we saw here, there's the application ID CA80. Looks like we're the same. I'll just, yep. And then 3180, I think we're the same there too. Yep. Yeah, so nothing changed, just the callback URI did. So now we're kind of all set basically to access this GitLab user and project, which I set up ahead of time. All right, so and then we kind of walked through all of the other items that were in the device here. They are in the environment. There's this RPC secret I'll just talk about real quick. So as I mentioned, that's the way that we talk between the main device and the worker that we're going to set up. That was just set up using OpenSSL. You can get OpenSSL to just spit out random hexadecimal, values, and so that's what that's for. And then if you're not familiar with a lot of DevOpsy stuff, that you can SCP, or you can basically copy things across the network to different computers. And so that's where we can use our IP address here, and we can copy these environment files that we've just kind of set up here for ourselves into a new environment. Let me paste this in, and we'll be all set to go for when we. So that's kind of our next step. We need to get our new environment out to this computer that we're logged into. I'm going to actually use a second shell window to do that. And here is our environment secret and environment sh file. So I'm going to copy those this way, quick and easy. There we go. So those environment variables are now out on our cloud instance. So now we can kind of run the money guy right here. And so real quick, so we're telling Docker to run the drone image where the drone guys have already set up basically a container that runs drone. We're naming it drone. We're going to restart it so that, you know, if this droplet on DigitalOcean gets restarted or whatever, it's going to start up our drone instance. Our CI is always going to be running. We're going to publish it on both ports, but really this is the secure sockets port. This is just regular HTTP port. So you could leave this out if you weren't going to run SSH. I leave it in there so that you guys can see that. And then we're pulling in both our client secret as well as the environment file env.h. And then setting up this volume is what allows Docker to save the drone data over time. So all of these containers that Docker creates are ephemeral. Any of the data that is stored in them, if you don't take specific precautions, it will be lost at the end of your session. And so you need to do something like this: create a volume, and then tell it /var/lib/drone inside of the droplet on DigitalOcean is where we want to store like our permanent data over time. And then /data is on the inside of the Docker container. And that is what helps us run this whole thing. So, I'm going to run the env secret. So we have the secret key, and then I will run our Docker command. And you see it will pull all the layers for drone, and then it will start up drone. And if we run Docker PS, that shows us that drone is running. Let me get this out of the way. There we go. So that's all it takes, and now we've got drone sort of up and running. Let's pull it up. Let's see what it looks like. So we will take, and to do that, we'll take the IP address that I've got right here, and we stick that in the URL bar, and it's running at port 80. So there we go. And now what we're seeing is an issue with I think probably my cookies from running this last night. What we need to do is clear out my cookies for this site. Oh, there we go. It figured it out. So anyway, so this is pretty cool. Like pretty much out of the box now, what it's done is it's figured out that I'm logged in to GitLab already. It's gone to GitLab and figured out who I am, and then it's synced all of the devices out on Dojo 5 public that my username can see. So basically, you'll immediately see a list of all of the stuff that I have. And to be clear too, like if I weren't logged in, I would just I would be directed to GitLab's login page. So it's not like this is just sitting out there for the whole world to see. Like this is a secure but a smooth, you know, kind of setup and transition here. So I think that's pretty cool. You can see here, I've got a couple of drone examples that we're going to be using. So drone hello world is kind of the first one. And that, I mean, really going back to the slides, we have pretty much set up drone at this point. we copied our secrets to the cloud server. We set up our environment. We have not yet spun up another runner, and we haven't installed the agent. But we're pretty close to ready to go here. If we were to let me get this out of the way again here. If we were to hit activate though, here we'll see what happens. So activate repository is how drone kind of puts its hooks into your repo. So I can hit activate, and we can say project visibility is private. You'll see that there's a YAML file that we'll talk about in a second that kind of is how you control drone. There's a couple of other, basically settings that you can set here. Have a cron job, which basically means you could run something hourly, daily, weekly, monthly. Add secrets, which we'll talk about later. And then you can see your branches and your activity feed. So this is cool. What we'd find though is if we tried to kick off a build right now, it would and by the way, there's no way to force a build here. You actually have to push something to the repo in order to get that to happen. So we would have to go to the hello world. Let's just do it so you can see what that looks like. So here's the hello world repo. I've got a test.txt file that I can, through the text editor here, I can just make a quick change, commit my changes, and then we'll see right away over here. It's already found those changes. It caught them. It saw that I updated it, and it's pending. And so the whole reason it's pending right now is because it has no way to run. We have no runners hooked up to this drone instance, and so the next thing we need to do is set up that runner. This is largely the same as what we did before. So we'll create another droplet in DigitalOcean. You can't run it on the same server. You do need to have two running, just because they communicate over sockets, and it doesn't appear to work if you keep it on the same one. But another Docker instance, we will make sure that it has my SSH key again, and then we're going to name it D5 worker, and we'll create this droplet. Let's take a second. This one doesn't need a floating IP because we're not going to be hitting the website or anything, so it can kind of sit wherever it needs to. And I'm going to use this third tab to connect to our worker. We'll see, it does take just a second sometimes to start up. And what we're going to do with that worker is we're going to, there's really not too much to it. We're gonna send our environment variables again to it. And in this case, let's see, where did code go? Yeah, so we're going to send the same environment variables to it, but in this case, these are there are some additional things that are required for the runners. So these are the environment variables for the runners. We have to tell it what's the protocol that's being used and where's our host. This is the IP of where our primary is running. How many jobs can it run at one time? Or we'll let it run 2 for now. You could crank that up depending on what you're doing. And then the runner name, D5 worker. So now I think we should be able to see that. There we go. Now it's up and running. We're connected. So cool. All right. And let's see. This guy is running at he is at this IP address. So we're going to copy our environment files over there. And really, in this case, we only need the one. So we're going to run our SCP command once again. But in this case, we're going to only copy the environment.sh. And this is just saying that we're copying, as the user root, we're authenticating as the user root to that device and then putting it in the root directory. All right, so now we've got our environment that we need over here. Now we can run the drone runner. And you can see this looks largely similar to what was happening up here, but we've got a few extra things. We're sharing the Docker socket from the host OS inside of the Docker container. This can be a security risk, so think about this before you do it. But this is what they call Docker in Docker. So like our runner is going to be kicking off Docker containers as it runs different steps of the build, and so it needs access to the top level Docker engine in order to do that. That's what this is doing. There have been some folks that have been able to get out of kind of the containerization of it. So this could be a controversial step, but because we are having our runner run on a completely separate machine from our primary, the only exposure that you have is stuff that's on the runner at the time that the runner's running. So you can do things like only allow it to execute one thing at a time, and then it will delete and clean up after itself when it's done, and then there's really a very minimal exposure there. It's a fairly secure setup. And then we're gonna pull in our environments. In this case, the runner actually uses port 3000 to do its to connect with the main, the primary, but otherwise it's very similar. And then in this case, we're grabbing the drone runner Docker image rather than just the drone image, but very similar to what we ran before. Grabbed it, and we're up and running. And then we can use another tool from Docker called logs to see if it's connecting all right. And so you can see that actually, so this will show the logs that are printing out inside of that container. And it started the server, successfully pinged the remote server, and now it's pulling the remote server. So that's what you should see if it's up and running. So that's great. And now what we should see is if we flip back over to our build, it was pending and waiting forever, and it already picked up that, hey, I've got a runner, and it already ran. So here you can see how drone kind of lays this out. It first pulled drone Git, which is basically the plugin so that drone knows how to use Git. And then it went and grabbed our Hello World app that we were pointed at, or our repository that we were pointed at, and went and grabbed our master branch and checked it out. And then as far as the build, what I did in this build, and we can go look at that real quick, is I created a drone.yaml ahead of time. And this is a good time to talk about this. So drone.yaml is a file that you check into the root level of your repository, and it defines the build steps that drone will execute. In this case, the top part is kind of boilerplate. You'll need a pipeline. You need Docker, or we're running it as a Docker type of pipeline, and the name is default. You can see that gets reflected here, but otherwise it's kind of an arbitrary name. And then you have a series of steps. Tough part for the new players sometimes is this is all in a format called YAML. And if you haven't used YAML before, the one thing that always catches new people with YAML is that it's exactly two spaces in front of each indent. It cannot be 3, it cannot be 1, it has to be 2, and it has to be spaces. So as long as you go 2 spaces, you're usually good with YAML files. But yeah, so here you basically can have an arbitrary number of steps. Every step starts with this dash space, and then you give it a name, you give it an image. In this case, every time it uses the word image, it's really talking about a Docker image. And Alpine is a Docker image that's pretty popular and publicly available. That is a very small Linux installation. So it allows us to do things where we don't need to get too crazy with Linux. Back when we were looking initially at the Dockerfile for Nordic, it was pulling in Ubuntu, and that's because the Sager Studio tools require a bunch of dependencies that come through Ubuntu. But in this case, all we wanted to do was just echo, this is a build step. And so we were able to run this on the Alpine image. And this is, in fact, Alpine latest, which latest just means give us the latest version of Alpine. And as we see, then there was the clone step is one that's kind of built in. And then the build step, which is us first, it grabs the Alpine image. And then it runs our command, which was this is a build step, and there we see this is a build step complete. We can restart it here. It would run again. This is a pretty fast build, 3 seconds, and we're done. So that's really cool. You can have, in more advanced scenarios, you can have multiple pipelines. You can actually have multiple pipelines where like each pipeline would run in parallel. So you'd actually see a couple show up down here. You could have, instead of default, it could be like the Mac build, and then you could, or I don't know, for embedded, you'd do like a, like the ARM64 build, for your bigger, beefier system, and then the ARM32 build for the, another flavor that you need to build your firmware for. Or maybe you've got 4 or 5 different micros on your device, and so like you could have parallel builds for each micro, because they don't necessarily need to depend on each other. A lot of times they can run in parallel, and you just have to have enough runners and enough executors in order to run all of those. So that kind of takes us through the embedded, or I'm sorry, the hello world. Let's now look at what the embedded CI piece looks like. So our goal will be to build a Nordic project via Sigger Studio. And there's one new requirement with this, because we're going to start, now what we want to do is we want to save our artifacts out. And while Jenkins and some other CI tools have that built in, Drone does not. And so we need to bring something else to the table. Drone Minio or Minio, I'm not totally sure how it's pronounced, is an S3 compatible and can be self-hosted. S3 being Amazon's S3, which is basically like a cloud-based file store. It's almost like a shared drive on the internet that's secured. And then this is where we'll also show off the secret store and how that works inside of Drone, and how you can kind of protect your builds from folks. Next step is to install Minio, and we're going to install this on the same server that our main web server is going on, so our primary server. The first thing, and I've already done this, but I just want to show you this again. So Minio requires you to have a access key and a secret key. It's an ID and a password, pretty much. But again, you can run OpenSSL, ask it to give you a random 16 byte hex, value, and use those as run it once for your ID and run it again for your password. It gives you, basically cryptographically secure random numbers there to use as your user ID and password. So that's what I already did up here. And I tossed it into our environment sh. Here's my access key and secret key. And we will, for the purposes of starting up this Docker image, we already have it actually up on the primary, right? We've already got this env.sh that we tossed up earlier. So we can just run it like this. Again, we're doing some things that we've done before here. We're exposing port 9000, which is where Minio ends up living. We're creating a volume, which is this persistent store for Docker images to store their information. So again, inside of our, and actually I want to change this. Inside of our host OS, it's going to be /var/minio. That's where we're going to actually store our stuff. But inside of the container, it's going to be at /data. And you see that in this case, Minio, you actually pass that as a parameter when you run Minio too. When you tell it to run the server and use /data as the data store, that actually gets mapped to the host OS in /var/minio. That's just so our data doesn't get erased once we shut down the container. Again, we're grabbing the environment file, and then we're telling it to restart and detach, so that basically this kind of will start up every time now. It'll be resilient. Okay, so we'll run that, and now Minio is running. So let's go take a look at that real quick. And where is our, yeah, here we go. So, and we're gonna go to port 9000 now. And now we'll see that we were initially asked for an access key and a secret key. We can go grab those just so we can kind of poke around in the in the user interface here. Now you could have like your QA team access it this way, but you can see that it largely just looks like a file store. I guess the big thing is they have a top level item is called a bucket, and that's the same terminology that AWS S3 uses. And so it's kind of like a drive almost, if you want to think of it. You think of a bucket as a drive, and then under the drive you can have folders and files just like you're used to. But you kind of have to create that initial drive. And in our case, we specified that. Where did I specify that? Oh, that's coming. So we're not quite ready to set it up yet, but we do have a we basically at this point we've got a place to store our artifacts that is fast and easy and quick to set up. So and even running on the same server. All right. So now what do we need to do? So now we're going to walk through the drone YAML that we need to create for this build. I mentioned kind pipeline type Docker named default. That's kind of our standard boilerplate stuff. We're also going to add a workspace key with a path to drone. And by the way, all of this stuff is there's a lot of complexity in the drone YAML if you need it. All of it's documented online, of course, with the drone tools. But in this case, we need a workspace to share. Because we're going to have two steps in our pipeline. We're going to have one step that does the compile, and then we're going to have one step that uploads the artifacts, the hex file and the elf file and whatever we need for our firmware. So /drone is going to be our spot in between steps of the pipeline to store stuff that we want to save off. We're going to have one step that's going to be called build. We're going to grab a Docker image that I've created. That has Sager Studio and specifically, certain versions of Sager Studio and the SDK from Nordic. So, the nice thing about this is very well controlled. Of how I always know I'm getting the same version of Sager. I'm always getting the same version of the SDK, and then some commands to actually build. In this case, we're changing directories into the SDK and going to one of their sample applications, a Blinky application. Yeah, it's wrapping a little bit, so sorry about how that's wrapping. And then we call Sager Studio's EM build tool, which is their command line build tool, and pointed at the project file. And then we copy the output to the drone directory, which is where we're staging all of our information that we want to save. And then we have another step called upload that uses drone's plugin system. So there's a number of plugins, and I can show you right here. Plugins, drone, yeah. So there are a number of plugins for drone that are available here. I don't know. Yeah, there's a zillion of them. And I think they've done a better job, I feel like, than Jenkins. Well, Jenkins just has a long history. And they have a lot of plugins, some of which are not well maintained. I think they recognize that you don't need 1,000 plugins. You probably just need 50 or 100 to kind of do a lot of what you need to do. And so I feel like I have a little more trust in these plugins than sometimes I do with Jenkins. But they're it's still something that you want to keep an eye on. But yeah, so we're going to use plugins S3, and because MinIO is compatible with S3, this will work, and we're going to point it down here at the endpoint. We're going to point it at our instance, and imagine that's the IP number that we've done, and at 9,000. And then we're going to point it at a bucket called Nordic firmware. So we're going to go create that bucket real quick. And then there's the access key and the secret key, and we're going to grab those from the secret store. So it's poor form, and don't do this, but some naive folks that are doing this for the first time might just grab the password right out of here and just check it into their put it in their drone YAML. Well, then that gets checked into your repo, and gosh, if that repo ever becomes public, even for a second, there have been instances, and this has happened to folks I know, where they accidentally have a repo that's public and somebody accidentally checks in a key, and there are folks that are scanning on GitLab and GitHub and Bitbucket for public repos that, and they know what keys might look like. They know what AWS keys look like. And so they'll scan for those in an automated fashion with a huge army of robots. And once they find them, they own you, and they either, expose, customer data, or they, hold it hostage or whatever, right? So that's why we don't ever check in, any kind of passwords or anything into your repo. And most systems have a way to hold secrets, and this is what we're doing here. We're referencing our secrets. Then we're gonna say the source of the stuff we want to upload is everything in the exe/star directory. And so this build step is going to start inside of that workspace that we declared up here, the workspace/drone, and it's going to look for an exe directory and grab everything inside of it and then stick it in the S3 bucket at builds. And then we're going to use an environment variable called drone build number so that we get like a nice directory per build. And that kind of takes us through the whole drone YAML. So we've got a couple action items. We need to create our bucket, and that's done with min.io simply by creating the bucket here and giving the bucket name. Now we have a bucket. We can see one over here, and we could create paths. We could upload files if we wanted to, but of course our system's going to do that automatically. Just emphasizing the fact that it's just like any other shared drive kind of. And then we need to add our access keys. So what we're going to do here is, and we're going to be on this Nordic build. This is where I've already set up the drone YAML file that I mentioned there. And here's where we can keep our secrets. So here we do the secret name and then AWS key ID. I'll go grab that from here. Add a secret. And now we have that secret here, and you can't actually retrieve the secret now from the UI. It's kind of a one-way deal, but drone is able to decode it internally when it does the builds, and it tries to protect that. And let's see. So then we just need to add the other one, which is AWS secret access key. All right. All right, so now we've got our two secrets in place. So now it should understand how to build. Okay, so now what it's doing is it's just waiting for something to change. And so now if we go, not drone hello world public, but go to the drone Nordic build repo, now we can push maybe a change to the README that just says, test. Commit those changes. There we go. So now it's found a device that's running. Now we can see it's running the build procedure. So it's pulling the SES, the Sager Embedded Studio environment. First time, this does take a little bit of time. That environment, especially since it's based on Ubuntu, is fairly large. It's almost a gigabyte, and that's one of the challenges you'll find as you start working more and more with Docker and reproducible environments. Is it's really easy to make a very large image, and it takes skill to make a smaller image. So that's that's the goal here, is to do our best to get it down. Okay, so now it's moved on. It grabbed the image, and now it's gone to the right directory, and now it's running the actual build. And now it's copying the artifacts, and then it did the upload, and it successfully uploaded our stuff. So now if we go over to the min.io browser and we refresh here, we'll see that under Nordic firmware, we've got a build directory, and it's build number 1, and here's our exes, and here's our elf file, map file, and hex file. So at this point, from this point on, your team makes changes to your code in your repository. Drone will be running securely out in the cloud. Infrastructure that we've set up right now costs $15 a month. You could maybe do it for 10 if you really wanted to really be cheap on cost, but it really doesn't cost too much to get this going, and you have so much better visibility into what you're doing and whether the build's broken, what you can imagine other steps, and I'll just kind of highlight those here that you could put in. Hill testing is a big one, and we'll be doing a lunch and learn on that coming up in July. Specifically, like kind of starting where we left off on these talks, and then talking about how do we integrate hill testing into something like this. Being hardware in the loop. So this is like, can we actually push these hex files out to a device that's kind of instrumented up so that we can test that it's passing some type of acceptance test. OTA updates and deployment. That's getting even more advanced. Drone might not be the right tool for that, although you can probably make it do something like that. Manufacturing releases, static analysis is another really nice one that we'll be talking about next month, and security checks. Both of those kind of go together. And then there's, we have some medical customers that like additional documentation and other things to be generated out of their embedded devices. So lots of basically there's and as I mentioned, the web guys and the mobile guys have all kinds of cool tools, and this is basically catching us up with an embedded flavor to where we want to be. And with that, take any questions that anyone has, and feel free to hit me up afterwards if desired.